Hi everybody, hi. Welcome to Momentum with Vedantu, guys. Welcome to Momentum with Vedantu. Ritesh Pathak is there, Adi Jagannathan is there. Superb, guys, superb. Let's start today's class. One second, let me see if my chat is refreshing. Yes, I think my chat is refreshing now. Hi everybody, hi. So guys, JEE Advanced is right around the corner. JEE Mains results are out. We are supposed to prepare for 2020 lectures. Okay, now the thing is, I have prepared this lecture today for friction. Friction is a very important topic and it's a very confusing topic because students are very confused about the direction of friction, where things will move, so on and so forth. So we are going to try and focus on those things today. Okay, clear the doubts where confusions generally happen. What will be the direction of friction? What will be the value of friction? These are the two main questions that we will ask for all this. Okay. Akash Gupta, this is not an Hindi channel, this is an English channel. Hi Ritesh Pathak, હું મજામાં છું, તું કેમ છો? Hi Adi Jagannathan. Okay, hi Akash Gupta, Deepika Gupta. Hi everybody. Hi. So today guys, we are going to study about friction. Okay, this is supposed to be done in one lecture and I will try my level best to do it in one lecture. But friction is a very complicated lesson and so it sometimes might go beyond one lecture, but we will try to finish as much as I can. Okay, so let's start to do friction. Okay, and we will mostly focus our attention on static friction because that is where all the confusion and all the good questions, the advanced level questions come from. Okay, mostly from static friction, and we'll do a little bit of kinetic friction. Okay, mostly static, a little bit of kinetic, mostly static, and a little bit of kinetic. Okay, that's what we'll do. So let's try to do that. Let's try to do that. First of all, hi everybody, hi. Okay, so next, let's start with the direction of friction. Okay, guys. Now, there's so many people get confused here. So remember this, guys. Remember this. Okay, and we'll do a lot of questions. We have to first remember this basic fact. Friction opposes a relative motion between two surfaces. Friction opposes relative motion. It doesn't actually oppose motion. It opposes relative motion. Hi Tawheed, hi Akash Dev, hi Hina, hi. Alright. So let's do this. Let's do this. Okay. So what exactly will be the direction of friction in the following cases? I'm going to ask you a question. The answer is either A or B. You have to give me the answer. Okay. Everybody, can you guys hear me properly? Can you guys hear me properly? Yes. Dr. Mohammed, can you hear me properly? Yes. Okay. Hi, Tawheed. Yeah, I know, Tawheed. Doctor, can you increase your sound? I think that would work. That would work. Okay, guys, give me the answer for this. It's a very simple question. Very simple question. Give me the answer. What will be the direction of friction on block A? What will be the direction of friction on block A? Everybody knows. Everybody knows. UWO told me correctly. Entertainment 2015 is also correct. This is a very simple question, guys. Here, if you see, the block will move towards right, so the force of friction will be in the backwards direction, like this. Okay, now you have to remember that force of friction always forms an action reaction pair. Okay, it forms an action reaction pair. Okay, what do I mean by that? That if there is force of friction on the block, then there will also be the force of friction on the other surface, which in this case is just the ground. The ground will feel a force of friction in this direction, but in general, we do not care about forces on the ground, so we don't make them in the diagram. But you have to remember, force of friction forms an action reaction pair. If there is friction towards left on the block, there will be friction towards right on the ground. Okay, you have to remember that. The answer to the first question, I think everybody gave me correctly, it will be towards the left. Okay, next question, guys. Next question. Now this one is a little bit complicated, but I think everybody will be able to tell me what will be the force of friction, direction of friction on block A. Once again, let's talk about direction of friction. Okay, what will be the direction of friction on block A? What will be the direction of friction on block A? I think my sound is very low right now. I think I need to increase my sound level somehow if I can. Hello? Okay, hello? Yeah, I think I will talk like this. I think that would be better. Okay. Oh, I don't know. In the frame. Yeah, I'm in the frame. Okay. Tell me the answer for this, guys. Tell me the answer to for this. It will be towards left or towards right. Now, here once again, everybody is giving me very good answer. Correct. Then Sunny Babu, you gave the wrong answer. Okay, the correct answer here. Ritesh is correct. Entertainment is correct. Very good, guys. Very good. Very good. It will be towards right in this case. Okay. Why am I saying this? Okay. So whenever you have to calculate direction of friction, you have to follow these two steps. Okay, step number one, for a minute, for a minute, imagine there was no friction. Imagine no friction. For a minute, imagine no friction. Okay, and secondly, see how bodies move in that case. Okay, see how bodies move in that case, and friction will oppose that moment. Friction will oppose that moment. Okay, what do I mean by this, guys? What do I mean by this? Imagine for a moment, in this case, there was no friction. Okay, imagine for a moment, in this case, you know what? I'll remove all of this because it's coming into my way, making everything complicated. Okay, so imagine for a minute, there was no friction. Okay, if there was no friction, guys, how will things look? In that case, how will things have looked? Okay, how will things have looked? So if there was no friction, you know that this block which is at the bottom, this block which is at the bottom will have moved in this direction with certain acceleration. Okay? Yeah, and if there was no friction, this block at the top would have stayed at rest. Okay, if there was no friction, this is what would have happened. This is what would have happened if there was no friction at all. Now, friction opposes this relative motion. Friction opposes relative motion. Okay, friction opposes relative motion. If you see, in this case, the relative motion is, in this case, the relative motion is that the block A is leaving there only and block B is moving from down. Okay, block B is moving from down, block A is staying from that. Friction will oppose this relative motion. Friction will oppose this relative motion. Okay, so what does that mean? Friction, what friction will do is, one second, let me get the my force. Yeah, friction will pull this body backwards, will pull back body B and pull forward body A. Okay, because the motion, guys, because the motion is like this, friction will try to make motion in the opposite direction. Friction will try to make the motion in opposite direction. Okay, the actual motion is like this. Friction will try to make it in opposite direction. I hope everybody understood. I hope everybody understood. Friction opposes relative motion. Now, if you understood that one, let's try to solve this one. What will be the direction of friction on block A? What will be the direction of friction on block A? Once again, tell me. What will be the direction of friction on block A? Sir, in case A, yes, Akash Dev. On A, it is C. In this case, oh my God. Here, if you see on A, the friction is towards right, and on B, the friction is towards left. Okay, on A friction is towards right and on B friction is towards left. In this case tell me what will happen. In this case tell me what will happen. What will happen? The friction on block A will be in which direction? Towards right or towards left? Towards right or towards left? Option A or option B? Ritesh Pathak is saying A and Entertainment 2015 is saying B. Amandeep Kaur is saying A. What? How? Hina Hanan V Biotonic is saying A. See guys, once again if you see, if there was no friction, if you forget about friction for a minute, then this body will go in this direction and this body will go in this direction. The top block A will go in this direction. Now friction does not like that relative motion. Friction does not like that relative motion. So friction will oppose that relative acceleration. Okay, so what friction will do is it will try to pull this block A towards right and try to pull this block B towards left. It does not like this relative sliding. It doesn't like the sliding. It will try to reduce the sliding. So on A, the friction will be towards right, and on B, the friction will be towards left. Okay, I hope everybody is following. I hope everybody is following. So on block A, the friction will be towards right. I hope everybody understood. I hope everybody understood. If you did, if you understood, please give me a thumbs up. If you have, if you did not understand, give me a thumbs down. Fatafat se, because this is important. The direction is super important, guys. Okay, once you understand direction, you can talk about the value. Okay, Sam Niran has a doubt. Sam Niran has a doubt. What is the doubt, Sam Niran? What is your doubt? Okay, now okay. Yeah, I hope everybody understood. I hope everybody understood. Okay. No, Sam Niran, the friction forms an action reaction pair, just like normal reaction. This is basics of Newton's laws of motion. Just like normal reaction is going to be up and down, similarly, friction is going to be right and left. Okay, it forms an action and reaction pair. It forms an action and reaction pair. On one it forms an equal and opposite. Okay, on one body it's towards right, on the other body it will be towards left. Equal and opposite, following Newton's third law of motion. Every action has equal and opposite reaction. Okay, now guys, let's go to the next question. This question is a little bit difficult. Okay, let's see if you can solve. Let's see if you can solve. This question is a little bit difficult. Oh, ho, 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 ho. Now I've given the value of masses and applying the force in the same direction. And oh my God, sir, what are you doing here? Tell me the correct answer, Jojo. Tell me the correct answer. Tell me the correct answer. Tell me the correct answer. It will be both. B, B. Hi, Abhyuday. Hi. It will be B or A, B or A, B or A. Entertainment 2015 is saying B, A, and Ratnesh is saying B. Okay. Oh my God. This is so weird. Huh? I love like so many different cases. How to solve this? So for this, guys, first of all, let's just remove this question. I don't like this question for a minute. Okay, so that I have space to write. Okay, now guys, remember what you have to do. For a minute, forget that there is friction. For a minute, forget that there is friction. Assume that it is smooth and see how the blocks will move. If there is no friction, see how the blocks will move. Now, if there is no friction, guys, then both the blocks will have certain acceleration. The lower block will have acceleration a1, the upper block will have acceleration a1, and let's say the lower block has acceleration a2. I can calculate both these accelerations. Okay, I can calculate both these accelerations. Now, if there is no friction, then acceleration of A would be F by m, that will be equal to 2 by 2, which is 1 meters per second square. And acceleration of B will be equal to F by m again, that will be 4 by 2, that will be equal to 2 meters per second square. I hope everybody understood. So, what I can say is that if there is no friction, this will move with 1 meters per second square. This will move with 2 meters per second square. Now, which will move faster? Which is going to go faster if there is no friction? Can you guys tell me which is going to go faster if there is no friction? Which is going to go faster if there is no friction? Can you tell me? Can you tell me which is going to go faster? B is going to go faster if there is no friction. Now, if there is friction, what friction will try to do, guys? If there is friction, what friction will try to do is not stop both of them. Okay, what friction will try to do is make them move together. What friction will try to do is make them move together. Okay, so if friction is going to try and make them move together, what friction will do is it will try to make the slow one faster and the faster one slower. It will try to make this one slower. Okay, it will try to make this one slower and it will try to make this one faster. Do you guys understand? Do you guys understand? It will try to make the faster one, the one which is going faster, block P, it will try to make it slower. And the one which is going faster, slower, it will try to make it faster so that they eventually move together. Friction, that's what friction wants. The friction wants both of them to move together. So it will try to increase this, it will try to decrease this. And if you see for that, the direction of friction on A, the friction will be towards right, and on B, friction will be towards left. Okay, you have to remember the direction, guys. Friction wants bodies to move together. Friction wants body to move together. Okay, so the correct answer in this case is on A, the friction will be towards right. On A, the friction will be towards right. I hope everybody understood. I really hope everybody understood. See, direction is very important and it's not easy as it looks, my friends. It's not as easy as it looks. Okay, let me give you one more example. Let me give you one more example. Let's see if you guys can solve. Let's see if you guys can solve. In this case, guys, tell me. Once again, I have just changed a little bit of data here. If you see, I have just changed a little bit of data here. If you see, now tell me what will be the direction of friction on block A. Okay, what will be the direction of friction on block A? Okay, tell me, guys. Tell me. What will be the direction of friction on block A? What will be the direction of friction on block A? Ah, la 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 la. La 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 la. Afra Baiju is saying hit the like button, guys. Please listen to Afra Baiju. Is correct. Oh, Ritesh Pathak is saying no friction. Oh my god. Oh my god. Oh my god. Sam Niran is saying option A. Shravani Reddy, hi to you. Okay, now guys, how to solve this? How to solve this? So once again, for a minute, assume that there is no friction. To calculate the direction, first let me get rid of all of this. Now, to calculate direction of friction, for a minute, assume that there was no friction. Okay, and then try to calculate both of their accelerations. Okay, if there is no friction and I look at the acceleration A1, then A1 will be equal to F by M, which in this case will be 2 by 1, which is 2 meters per second square. And A2 of block B will be equal to F by M, which in this case will be 4 by 2, will also be 2 meters per second square. So in this case, if you see, if there is no friction, then both of them are moving with acceleration 2 meters per second square. Now, if we introduce friction, then friction wants them to move together. Friction wants them to move together. But are they already moving together or not? Are they already moving together or not? Yes, they are, guys. Yes, they are. They are already moving together. Okay. So in this case, friction will not be there. Friction is not necessary. Okay, friction will not be there. Why will friction not be there? Because friction, the only thing friction wants is for these bodies to move together and they are already moving together. So friction doesn't care. The answer here is very simple. It's option C, that friction is zero. Okay, I hope everybody understood. The correct answer here is option C, that friction is zero. There is no friction in this case, guys. There is no friction in this case. I hope everybody understood. Did you guys understand? Give me a thumbs up if you understood. Give me a thumbs up if you understood. Okay. Right. Yeah, Amit Karwarkar. Oh, Amit Karwarkar is here. Yeah, it was a tricky question. It was a tricky question. Yes, exactly. Okay, sure. Sam Niran, if floor has friction, then things become very complicated. We'll talk about it at some other point. Okay, not right now. Right now, assume that the floor is smooth. Okay. But if floor has friction, then of course that friction will always be, if there is a floor is rough, okay, then the friction due to the floor will always be towards left. Okay, so that abhi ke liye, let's forget about it. Now one last question, guys. One last question. Okay, tell me the direction here of friction on block A. Okay, tell me the direction of friction on block A. Everybody should be able to give me the correct answer. Everybody should be able to give me the correct answer. La 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 la. Yes, Ritesh Pathak gave the correct answer. I remember Ritesh Pathak answer, reading Ritesh Pathak's answer. Active Ronak is also here. Hi, Active Ronak. Okay. Alright, guys. Tell me the direction of friction on block A. Tell me the direction of friction on block A. What will it be? What will it be? What will it be? Now, guys, once again, what do we do? Once again, let's look at this. Let's look at this without friction for a minute. For a minute, let's forget that the surface is rough. Okay, and assume that the surface is smooth. Now, if I assume for a minute that the surface is smooth, both of them will move with different accelerations, A1 and A2. I can calculate A1 and A2. I can calculate A1 and A2. A1 will be equal to 2 by 1, which is equal to 2. A2 will be equal to 4 by 4, which is equal to 1. So this is moving with 2 meters per second square. This is moving with 1 meters per second square. Guys, now if I have friction, then see, what does friction want? Friction wants both of them to move together. So what friction will try to do is, it will try to slow down block A and it will try to make the block B faster. It will try to slow down block A and it will try to make the block B faster. Okay, so on A, friction will be towards left, and on B, friction will be towards right. On A, friction will be towards left. Yeah, high five, Ajay Acharya. High five, high five. Okay, I hope everybody understood. I hope everybody understood. La 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 la. Okay, so the correct answer is option A here. Okay, this is how we determine direction of friction, guys. This is how we determine direction of friction. Yeah, entertainment 2015 ko chamak gaya. Very good, entertainment 2015. Okay, entertainment 2015. What is your correct name? Proper. What's your real name? Entertainment 2015. Okay. I hope everybody understood. I hope everybody understood. Okay, now that we understand the direction of friction, I hope everybody understands the direction of friction. Then let's talk about the second thing about friction, which is value of friction. Okay, let's talk about the value of friction. Now, guys, I think everybody knows. That there are two different types of friction: static friction and kinetic friction. Okay, I think everybody knows there are two types of friction: static friction and kinetic friction. Okay, kinetic friction is also sometimes called dynamic friction. Okay, and when two surfaces are not sliding with respect to each other, it's called static friction. If they are sliding, it's called kinetic friction. Everybody knows this. Okay, all right. So let's talk about value for each of them. Value for each of them properly. Okay, so now guys, what I did was, in this case, I did an experiment. Okay, I went into a lab and I did an experiment. And I got a lot of data and I noted down that data on this table. Okay, I noted down that data on this table and I'm going to tell you what data I got. Okay, what data I got. Okay, and based on that, we will try to understand what is happening. Okay, based on that, we will try to understand what is happening. So, guys, I went to a lab and I saw that there is a block on a rough surface. So, first of all, I didn't apply any force on the rough surface. Okay, if I don't apply any force on the rough surface, guys, do you think the block will move? Do you think the block will move? Can you tell me if the block will move? Yes or no? Yes or no? Sam Niran, I will reply to you. I don't know if I have replied to you yet. I think I have, but I will reply. Don't worry. Okay, if I apply any force, do you think the block will move? Do you think the block will move? No, guys, the block will not move. So if I apply a zero force, then the block will not move. And in that case, guys, if I ask you what will be the value of friction, can you tell me what will be the value of friction? Can you tell me what will be the value of friction? Yes or no? Yes or no? Yes or no? Can you tell me what will be the value of friction? What will be the value of friction? Anybody, anybody. See, this is the very basic question that everybody should know. What is the question? What is the value of friction? Yes, correct. Ritesh Pathak is correct. Entertainment 2015 is also correct. It will be zero. Okay. Why will it be zero? Why will it be zero? Because it doesn't need to be there. The block is not moving on its own. Nobody is trying to move the block, so there will be no friction. Okay, very good, very good. Umang is correct. Everybody, Dr. Mohammed is correct. Wow, very good. Are Jojo, there is nothing trying to move the block, right? There is nothing trying to move the block. So in this case, there will be no friction. Okay, because friction doesn't need to be there. Now what I do is, guys, now I start applying a force of 5 Newton. And now I'm just telling you what happened in this experiment. Okay, now I'm just telling you what happened in this experiment. Now when I applied a force of 5 Newton, now I saw that the block is still not moving. The block is still not moving. This is the experiment that I saw in the lab, guys. You just have to believe me. I saw it like this. Okay, so now in this case, guys, if I ask you what is the value of friction, can you guys tell me what will be the value of friction? Can you guys tell me what will be the value of friction? Can you tell me? Can you tell me? Can you tell me? Yes, yes, yes. Yeah, correct, correct. Entertainment, Ritesh, Jojo, everybody is correct. No, Jojo, you are wrong there. See, in this case, the value of friction with the direction of friction will be towards left, and its value will exactly be 5 Newton. Its value will exactly be 5 Newton because the block should not move. Because the block should not move. So its value will exactly be 5 Newton. Okay, only then, if this is 5 Newton, only then the block will stay at rest. Now, once again, guys, what happened is, by the way, this is which type of friction? This is a static friction or kinetic friction? Which type of friction is this? Which type of friction is this? Static or kinetic? Static or kinetic? Static or kinetic? No, it cannot be 6. Okay, Jojo has a very special doubt. Very special doubt. Let's talk about it. Okay, but tell me which type of friction is this, first of all? Static or kinetic? This is a static friction. Okay, static friction. Now, Jojo is saying, sorry, it can be 6 Newton as well. Now, Jojo, if you see, if the friction is 6 Newton, that means there is an overall force in this direction and the block will start having an acceleration in this direction, which is not possible. Do you think that is possible, Jojo? Do you think that is possible that I'm pulling the block towards right and it starts moving towards left? Do you think that is possible? No, it's not possible, Jojo. Okay, so this is not going to be the case. This is, oh God. This is not going to be the case. Okay, Jojo, no. No, Jojo, no. No, Jojo, no. Okay. Alright, now this will also be 5 newtons only. Okay, this will also be 5 newtons. Now, guys, once again, I'm experimenting. Okay, I have a lot of time. I'm experimenting. So, while experimenting, what I did was I increased the value of the force that I was applying from 5 Newton to 10 Newton. Okay, and when I applied the force of 10 Newton, I saw in the lab that the block is still not moving. Then tell me what will be the value of friction in this case? Then tell me what will be the value of friction in this case? What will be the value of friction in this case? Tell me, 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 tell me. What will be the value of friction in this case? Everybody should tell me the curve. Yes, entertainment, Bharti, Aryan, everybody is correct. Yes, it will be 10 Newton. And what type of friction will it be? It will still be static friction. Okay, it will still be static friction. Very good. Now, once again, I kept doing that experiment. Okay, I kept doing that experiment. So I increased it from 10 to 15. Okay, when I increased it from 10 to 15, it again did not move. I saw it and it did not move. Okay, and so I'm saying that okay, chalo, the friction is still static only, and it's equal to 50. Now, what happened, guys? Now, what happened is now I applied 20 newtons. Now I applied 20 newtons, and poof, the blocks start moving. It's a maximum. Now I applied 20 newtons of force, and finally the block started moving. Now, in this case, guys, what type of friction is the value? So I don't know. I will tell you how to calculate later. Just tell me what type of friction is this? What type of friction is this? What type of friction is this? Okay, what type of friction will this be? This will be kinetic friction. What type of friction will this be? Kinetic friction, and we will talk about the value of kinetic friction in some time. Value in some time. Okay, how to calculate that value in some time. Right now, let's focus our attention on static friction. Okay, similarly, if I increase the force from 20 to 25 Newton, once again the block started moving. Okay, once again the block started moving. This time also, I still don't know the value of kinetic friction, but it's just, let's say, some value, some value. Okay, we will try to calculate that later, not right now. Not right now, some other point, some other point. Okay, I hope everybody is following so far. I hope everybody is following so far. I hope everybody is following so far. Okay, I hope. Okay, now, now this takes us to my first point. Okay, this takes us to my first point. What is the first point that you have to remember? The value of static friction. The value of static friction is always going to be the value of static friction is always going to be whatever value is required, guys. Whatever value is required. Okay, it's not going to be equal to mu into n. I know everybody wants to say it's going to be mu into n, but not for static friction, guys. Not for static friction. The value of static friction is always going to be whatever value is required. Okay, similarly, if I talk about if I go one more step further, then at some point the static friction is not enough to stop the body from moving. At some point the static friction is not enough to stop the body from moving. Okay, so it goes to a certain maximum value and then doesn't increase beyond that. That value above which it cannot increase is called limiting static friction. Okay, it is called limiting static friction. So you have to remember two things about static friction. The first thing is that its value cannot increase. Its value is always whatever is required, but it cannot increase, limiting static friction. Okay, now based on that, let's try to first calculate limiting static friction. Okay, so we did a lot of experiment. Okay, once again, limiting static friction we'll try to calculate. It's written as FL or F max. Okay, it's denoted by FL or F max. Okay, so limiting static friction, to calculate that, guys, we did a lot of experiments. And you know what we realized? We realized that if I'm applying a force here and there's a force of friction here, okay, what we realize that the limiting static friction, the point at which the block just starts moving, that limiting static friction is directly proportional to n. What is n here? N is the normal reaction. N is the normal reaction. If I increase the normal reaction, then the value of limiting static friction increases. Okay, and if I want to remove proportionality, guys, what will I add? If I want to remove proportionality, what will I add? Tell me. If I want to remove proportionality, I will have to add a constant. What will that constant be called? That constant is called mu s, and mu s is called coefficient of static friction. Okay, now this depends on nature of surface. Depends on smoothness of surface, or basically nature of surface. Okay, some surfaces are very smooth and therefore have very small coefficient of static friction. Some surfaces are not very smooth, okay, and therefore have high value of coefficient of static friction. Now, guys, remember what you have to do. Okay, in the exam, always remember, this is for what? This is for static friction. Okay, this is for static friction. Okay, always remember to follow the following steps. The step one is always to calculate normal reaction. Step 2 is always to calculate FL, which is mu s into N. And then finally, then calculate, after you have done step 1 and step 2, then calculate the force of friction. Then calculate the force of friction. First, you have to calculate normal reaction and limiting static friction. Then you calculate the limit, क्या बोलते हैं, force of friction. Okay. All right. I hope everybody understood. Now, let's talk about kinetic friction. Okay, kinetic friction, guys, is very simple. I'm applying a force, the block is moving. What will be the type of friction? The type of friction will be kinetic because the block is moving here. Okay, this kinetic friction is is proportional to the normal reaction here. The kinetic friction is proportional to the normal reaction here. Okay, and and once again, if I want to remove the proportionality, I have to add a constant, and that will be equal to mu k into n. Here mu k is called coefficient of kinetic friction. Coefficient of kinetic friction. Now, guys, remember this. The value of static friction is what? The value of static friction is always whatever is required, which cannot exceed mu s into n. But the value of kinetic friction is always mu k into n. Okay, the static friction value can vary, but the value of kinetic friction is always mu k into n. Okay, based on this, guys, based on this, let's try to solve this question. Okay, based on this, I hope everybody is following. Let's try to solve this question. Simple question. You have to first find the value of limiting static friction. You have to first find the value of limiting static friction. Fl is equal to question mark. Then you have to find the value of F, and then you have to tell me, does the block move? Does the block move? Okay, first, second, and third, three questions I think everybody should be able to solve. Okay, everybody should be able to solve. Sam Niran, what do you want? Normal reaction. Niran, normal reaction you will have to see. I will tell you how to solve normal reaction. Here you have 4 into G in the downwards direction and normal reaction in the upwards direction. You can easily say N is equal to 4G, which is 40 newtons. Okay. All right. British Pathak is saying 16 Newton, 10 Newton, and no or on. I don't know what it's saying. Okay. So, first of all, guys, I hope everybody sees that the normal reaction will be equal to 40. Now, what will be the direction of, what will be the value of limiting friction? That will be mu s into n. That will be 0.4 into 40. That will be 16 Newton. Now, guys, remember this. The force of friction will be in opposite direction. But will force of friction will be equal to 16 Newton? No. Force of friction will not be 16 Newton. Force of friction is whatever is required to keep this block at rest. How much force of friction is required to keep the block at rest? How much force of friction? Yes, only 10 Newton is required to keep the block at rest. Okay, so the answer to the first question will be 16, the answer to the second question will be 10, and finally the answer to the third question, will the block move or not move? Tell me, will the block move or not move? Anybody? Tell me. Will the block move? No, it will not move. Okay, because I already have enough friction to keep the block at rest. Yes, Himanshu Yadav, static friction is an adjustable force. It's a self-adjusting force. Its value is whatever is required. Its value is whatever is required. Okay, guys. I hope everybody understood. Really hope everybody understood. Let me give you one more question. I think you guys can solve this. Okay. Next question. I have the same set, same row, but this time I have changed the force to 15 Newton. Now once again tell me limiting static friction, friction and will the block move? Limiting static friction, friction and will the block move? Okay. Are Sam Niran coming to your doubt, man? Don't worry. I understand the doubts that come in your head. Okay, I'm going to that only. Going to that only. Don't even worry, Resa. Don't even worry. Okay. Yeah. Alright, so what will it be if I apply 15 Newton force? Now once again guys, if you apply a 15 Newton of force, the value of this does not change. The normal reaction is still going to be 40. The limiting friction is still going to be 16 newtons. Okay, that is the same as the last data. So here the limiting static friction will still be equal to 16 newtons. Okay, and the amount of frictional force required, guys, how much friction is required to keep the block at rest? How much friction is required to keep the block at rest? 15 Newton is required to keep the block at rest. Okay, 15 Newton is required to keep the block at rest. So will the block stay at rest or will it move? It will stay at rest. It will stay at rest with a value of 15 Newton. The force of friction will not be mu s into n here, guys. It will be whatever is required. And will it move? No, it will not. No, it will not. Okay, I hope everybody understood. I hope everybody understood. Understood. Let me give you one more question. Let me give you one more question. Ta-da-dam, ta-da-dam. Tell me the correct answer, my friends. Tell me the correct answer, my friends. Will the block move or not move? Will the block move or not move? Tell me the correct answer, my friends. Entertainment, I don't understand what you're asking. Himanshu Yadav, this type of question, not in advance, but advanced, yeah, advanced is very conceptual. So if you understand the concept, then you will be able to do the advanced level questions. Okay, I will get to one advanced level question, but it is based on what I'm teaching right now. Okay, last question of this day is advanced question, so I will get to it. Don't worry. Tell me, guys. Tell me. Will it move or not? Once again, see guys, the data is same. The limiting static friction FL is equal to 16. Okay, how much force of friction do we need to keep the block at rest? We require 16 Newton. Can it take a value of 16 Newton? Of course, it can take a value of 16 Newton. So force of friction will also be 16. In this case, will the block move? In this case, will the block move? It will still not move. It will still not move. Okay, it will still not move. But guys, now is the big question. Now is the big question. Okay, will the block move now? Will the block move now? Will the block move now? Yes or no? Yes or no? Yes or no? Yes or no? Will the block move now? Yes or no? Static limiting friction is 16. Will the block move now? La 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 la. Yes, the block will move now. Yes, the block will move now. I need a friction of 16.00000001 newtons, which is not possible because the maximum value it can take, is what? The maximum value it can take is 16. So in this case, guys, what type of friction will be there? In this case, the friction will be kinetic friction. Which type of friction will be there? Kinetic friction, and its value will be equal to mu k into n, that is 0.4 into 40, which will be still equal to 16. So the friction here will be Fk, which will be 60 Newton. In the previous cases, we didn't have Fk, guys. In the previous cases, we had Fs and Fr. We had Fs and Fs. Okay, the static friction were there. Okay, all these cases we had static, but now kinetic friction because the block will start moving. Remember, the kinetic friction is always equal to mu k into n. Now, based on this, guys, if I ask you to make this graph, okay, we have to make the graph between F and F. So how will this graph look like? How will this graph look like? Okay, so if let's say I start increasing the value of this from zero, increasing the value of this from zero. So initially I was applying zero force. Initially I was applying zero force, and now slowly I increase the value of this. So what will this graph look like, guys? What will this graph look like? The force of friction will increase gradually like this. If I have a force of 1 Newton, the friction will also be 1 Newton. If I have a force of 2 Newton, the friction will also be 2 Newton, and stuff like that. Okay. But then at some point, the value of friction will reach the limiting value of static friction mu s into n. Limiting value of static friction mu s into n. Now, beyond this, guys, beyond this, it will not go further. It will not increase further. By the way, this angle is 45 degrees. Huh? Now, what will happen, guys? In general, in most practical situations, mu k is slightly smaller than mu s. Okay, very slightly smaller than mu s. So, after it starts moving, the value of friction will fall a little bit, okay, to mu k into n, and then it will remain constant. Okay, and then it will remain constant. In most practical situations, this mu k is slightly smaller. Mu k is slightly smaller than mu s. Okay, so the graph will look like this. Sam Niran, smart board is on the way. Don't worry, my friend, it will come. Okay. Alright, I hope everybody understood this graph. This is a very critical and important graph. Okay, you should be able to understand. You should be able to understand. Now guys, based on this, let me give you a question. This is the question. I have a 4 kg block kept on a block like this. Okay, you know what? Just to make things interesting, I'm going to make this 0.5. Okay, I'm going to make this as 0.5 or 0.55. Okay, now tell me, guys, tell me what will be the normal reaction. I'll tell you cos 53 is equal to 3 by 5 and sin 53 is equal to 4 by 5. Okay, tell me, what will be the value of normal reaction? La 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 la. Saksham Bansal. Saksham, देखो यार, if my demotivation is not enough to demotivate you, then you are on the right track, my friend. Then nobody can demotivate you, and in that case, you will do very well in your exams. Okay, so don't worry. Okay, now guys, tell me this question. Jojo, will they ask these type of difficult questions? Jojo, these questions are very basic questions. NEET will probably ask this, but NEET, for that you have to just focus on NCERT, mostly on NCERT. Okay. Yes. So anybody can give me the answer here, guys. What will be the normal reaction? Tell me the normal reaction. I know you want to tell me the normal reaction. Oh, Ritesh Pathak is saying 24 Newton. That is correct. Okay. Ritesh Pathak is saying 24 Newton. That is correct. First of all, guys, you have to remember to split this into two different parts. Okay. There will be 20 sine 53 in this direction, and there will be a force of component of 20 cos 53 in this direction. Okay, after you divide it into components, you have to remove the original force. And if you calculate 20 cos 53 and 20 sine 53, you can calculate 20 sine 53. How much is that equal to? 20 into 4 by 5. That is equal to 16. Okay, similarly, you can also calculate 20 cos 53. 20 cos 53 will be equal to 20 into 3 by 5. 20 into 3 by 5. That will be equal to 12. So I will just replace this force by two different forces. Okay, I will replace these two forces by two different forces, 16 and 12. Now, guys, if I ask you the normal reaction, you have to remember the normal reaction will be in upwards direction, the ground 4G will be in downwards direction. Okay. Now, in order to calculate the normal reaction, what I will say is total force up is going to be equal to the total force down. Okay, which gives me n plus 16 is equal to 40, n is equal to 24. I hope everybody understood this part. I hope everybody understood this part. Okay, now that you have understood this part, guys, let's do the next question. Find the limiting value of static friction. Find the limiting value of static friction. Can you guys tell me what will be the limiting value of static friction? Can you guys tell me what will be the limiting value of static friction? What will it be? 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 Limiting value of static friction. The limiting value of static friction. La 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 la. La 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 la. Yes, the limiting value of static friction will be F limiting will be equal to mu s into n. That will be 0.6 into 24. That will be equal to 24 into 6. 12 3s are 36 into 2 72. This will be 70. Oh, 24 into 6. 12 into 24 into 6. Okay, 12. 24 into 3 is 72 into 2 is 14.4 newtons. Yes, 14.4 newtons. Yes, correct. I hope everybody understood. Now the final question, guys. Now the final question. Will this block move? Will this block move? Everybody tell me the correct answer. Will this block move? Will this block move or not move? Yes or no? Yes or no? Yes or no? Yes or no? How do we know the block will move or not? Samnir, and yes, this is closer to advanced, but in advanced they will ask you to make the graph. Okay, that will be the actual advanced question. They will ask you to make the graph. Okay, now tell me, guys. First of all, tell me, will it move or not move? Not will move or not move? No, it will not move, my friends. It will not move. Okay, first of all, let's divide these two forces here. It will be 12 in this direction and 16 in this direction. Then the friction force will be in this direction. Now I know that normal reaction is 24 and limiting friction is 14.4. So force of friction required is only 12 newtons, which is less than 14.4. So therefore the block will not move. Block won't move. The block won't move. Okay, simple. La 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 la. I hope everybody understood. Let me give you one more question. Will this block move or not move? Will this block move or not move? Very simple, guys. Tell me. Always remember to follow the steps. Step number one is calculate and step number two is calculate FL. Okay, step number three is then decide move or not move. Okay, this is the step it will follow move or not move. La 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 move or not move. Sam Niran, don't ask me that, my friend. It will take ages to do that. Okay, it will take ages to do that. So guys, how to do this? How to do this? First of all, let's calculate normal reaction. Okay, first let's calculate normal reaction. For that, I will need to divide this into two different forces. This will be 25 sine 53, and this will be 20 cos 53. Okay, if I try to calculate the values of 25 sine 53 and 25 cos 53, oh god, let's do it first. If I calculate both these values, guys, these values will be 20 and 15. Okay, if you calculate both these values, it will be 20 and 15. Now, normal reaction will be upwards and mg will be downwards, and I can calculate not mg, 4g. Okay, I can say that total force up is total force down, in which case n plus 20 is 40 and n is 20. What to do from here? Let's try to calculate. What will we calculate now, guys? What will we calculate now? We will calculate the FL. Okay, we will calculate FL. What is FL? The limiting friction is equal to mu s into n. That is equal to 0.6 into 12 Newton. Now, guys, look at this. Now that I know that this is 12 newtons, now I can go to the next part. If you look at this, this is 20 and 15. Okay, let me write it properly. So this is 20 and 15. Now, if you see here, my force of friction will be in this direction. How much friction do I require? 15 Newton, which is not possible. Not possible. So therefore, the block will move. Block will move. I hope everybody understood. Yes, yes, yes. Okay, I think Harsha Vardhan and Ritesh Pathak and okay. Priya Karthikeyan, everybody gave the correct answer. Superb, guys. Superb, superb, superb. Let's do one more question. Tell me whether it move or not. Tell me whether it will move or not. Tell me whether it will move or not. Okay, this is a hard question. No, this is not that question. This is the question where find the maximum value of f. This is a good question. Find the maximum value of f for which the block stays at rest. Find the maximum value of f for which the block stays at rest. Okay, find the maximum value of f for which the block stays at rest. Guys, how to do this, how to do this, how to do this, how to do this, how to do this. Tell me right now how to do this. Samiran, how to draw the graph is very, very hard, my friend. You have to write an equation. In that case, you will be able to solve. Okay, now, huh. Everybody tell me whether it will, what is the maximum value of f for which it will stay at this. Now guys, when you are solving a question like this, okay, how to do. See now, in this case, they have asked you a they've given you a very, very simple instruction. You have to find the maximum value of f for which it will stay at rest. So what you do is you take the boundary case. You take the boundary case. What is the boundary case? You know that the value of friction, can only go as high as limiting static friction. Okay, so what you will do is you will here directly assume that the value of friction, the value of friction is equal to limiting static friction. You will assume this as a boundary case. The value of friction you will assume as directly equal to the limiting static friction. It's not always true, but whenever you have the maximum and minimum questions where the block is already just about to move, you can assume its value to be limiting static friction, which is mu s into n. Okay, so let's solve it like that. I will have a force of friction in this direction. F in this direction. I will have a normal reaction in the upwards direction. And this force F can be divided into two different components. It will be F cos 45 here, okay, and F sine 45 here. What other force will be there, guys? What other force will be there? There will also be a force of 5G in downwards direction. Now, if you see, guys, okay, one second. Now, if you see, I can easily write the value. Let's remove this, all of this, like this. Okay, I can easily calculate the value of normal reaction, guys. What will be normal reaction? I can say the total force up is equal to the total force down. Okay, in which case N is equal to F sine 45 plus 50. Or I can write N is equal to F by root 2 plus 50. I hope everybody understood. Okay. Also at the same time, guys, this is not moving, but it is just about to move. This is not moving, but this is just about to move. In which case, what I can say is that this force should exactly be equal to mu s into n. This force will exactly be equal to the limiting static friction. It's just about to move. The force of friction will become equal to the limiting static friction. Or I can write F cos 45 is equal to FL. Or I can write F by root 2, cos 45 is 1 by root 2, is equal to 0.5 into n. Now, if you try to solve this properly, then in that case, normal reaction will be equal to F by root 2 plus 50. Okay, now if you solve this even more, guys, if you solve this even more, then what will you get? If you solve this even more, very. Friction always opposes relative motion, my friend. It always opposes relative motion. So in this case, if you try to solve this, what will you get? You will get f by root 2 into 1 minus 0.5 is equal to 0.5 into 50, which gives me f is equal to 50 root 2 newtons. After some maths, you will get f is equal to 50 root 2. So at this point, at this force, it will be just about to move. If I increase the force even a little bit, this is where it will move. Sam Niran, yes, this question will be there in JEE Mains. This is the exactly typical type of question that you get in JEE Mains. Okay, this is the typical type of question that you get in JEE Mains. I hope everybody understood, guys. I really hope everybody understood. Okay, all right. Jishnu, yes, you are exactly one. You are exactly 1 hour late, my friend. You are exactly 1 hour late. Okay, guys. So now let's talk about some other terms of related to friction. Okay, let's talk about some other terms related to friction. There is something called contact force. There is something called contact force. What exactly is contact force? So, guys, if you have a surface like this and a block like this, okay, and let's say you are applying a force in this direction, then in this case, this surface will experience two different forces. One in upwards direction called normal reaction and one in horizontal direction called friction. Okay, one in upwards direction called normal reaction, one in horizontal direction called this. It's okay, Jishnu, it's okay. So now the resultant of these two, okay, the resultant of these two, friction and normal reaction, is called the contact force. You have to remember F and N are both there due to surface of contact. Okay, both of them due to surface of contact. So their resultant the contact force. This force is called the contact force. This force is called the contact force. I hope everybody understood, guys. Really hope everybody understood. Okay, guys, now there is one more term here that you need to know. There is one more term here that you need to know, and that term is called angle. Okay, I will write it in black. Black suits me more. Okay, it's called angle of friction. It's called angle of friction. What exactly is angle of friction, guys? What exactly is angle of friction? This angle made by the contact force with the vertical is called angle of friction. This angle is called angle of friction. Theta. Theta is called angle of friction. Okay, and what will be the value? Well, you can find the value of different things. You can say cos theta is equal to n by c. You can say sin theta is equal to f by c. And you can say tan theta is equal to f by n. Okay, now if you know any of these three values, let's say you know the third one. If you know the third one, then from that, using that, you can calculate the value of theta. If you know the value of tan theta, you can calculate the value of theta. Okay, Jishnu, no, I mostly on Vedantu platform I teach JEE students. Okay, all right. but this channel here is for both JEE and NEET students. Okay, I hope everybody understood, guys. I hope everybody understood. La 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 la. Okay, guys. So next is a topic something called angle of repose. Angle of repose. Now, in order to understand angle of repose, I will need to tell you something like this. Let's say I have a book here, guys. Let's say I have a book here. I hope everybody can see this book and see my favorite book. Okay, my favorite book in the entire world. I'm telling you guys, this is where if you're preparing for NEET, especially, this is my favorite book. If you're preparing from JEE, also just finish this first. Okay. Anyways, so if you have a book like this, and let's say I keep a small object on it. Okay, you can see this object. Okay. Now, what I do is I start inclining this. I start inclining this. I start increasing the angle, increasing the angle. It's still not moving. Do you see that? It's still not moving. But what happens is, oh, what happened, guys? It fell down. Okay, up until a certain angle, up until a certain angle, it will not move. But then, if you increase angle even a little bit, it will slide down. You increase the angle even a little bit, down. The angle at which it slides down, guys. The angle at which it will slide down, the body will slide down the inclined plane is called angle of repose or angle of repose. I don't know. Okay, which book was this? This is NCRT book. This is NCRT book. I'm not sure also. Okay, the angle at which it just falls is called angle of repose. Okay, I want to know, no, it's not HCV. It's not HCV. Okay. So I want to know the angle at which the body just starts falling, or the maximum angle up until which it doesn't fall. I want to know that angle. That is called angle of repose. How do I calculate that angle, guys? How do I calculate that angle? Let's say I have an inclined plane. Okay. So I have this angle theta. Okay. Theta is the angle at which block just starts sliding. Okay, no, actually that's not the correct definition. Theta is the maximum angle up to which the block does not slide. Okay, theta is the maximum angle for which block does not slide. Block does not slide. Okay, which block am I talking about here, guys? Which block? I didn't make any block in the diagram. Let's make a block here. Let's say I have a block of mass m here, which is on a surface having coefficient of static friction mu s. Now, how do I calculate this angle of repose? How do I calculate this angle of repose? Okay. How do I calculate this angle of repose? So what you can say here is, guys, that this block will feel two different forces. First, it will feel mg sine theta in this direction, and it will feel mg cos theta in this direction. These are the four components of mg along and perpendicular to the plane. Okay, also at the same time, this block will feel the normal reaction in this direction and force of friction in this direction. Okay, now guys, what I can say here is that since the block has not yet started moving, I can very simply say F is equal to mg sine theta. Okay, F is equal to mg sine theta, and the normal reaction is equal to mg cos theta. Okay, normal reaction is equal to mg cos theta. Now, if the block is just about to slide, is just about to slide, then what I can say, guys, then what I can say is that force of friction is mu s into n. Force of friction is mu s into n. Or I can say mg sine theta is equal to mu s into mg cos theta. Okay, now if you see, some things will get cancelled out here, some things will get cancelled out here, and I can very simply say, guys, I can very simply say tan theta is equal to mu s, which gives me theta is equal to tan inverse of mu s. So, guys, if you keep this inclined plane at an angle of tan inverse mu s, then it will just slide. If you increase the angle even a little bit more than this, then the body will start sliding. Then the body will start sliding. I hope everybody understood. Really hope everybody understood. Now, guys, at this point of time, I'm going to give you one homework question. Okay, this is the homework question. This is the homework question for you guys to solve. Please write the answer in the comment section. Okay, answer in comments. Answer in the comment section. Tell me the force of friction and also tell me, does it move? Does it move? Okay, always remember, guys, always remember, to know whether it moves or not, you first start by calculating normal reaction and then limiting static friction. Okay, and assume G is equal to 10 meters per second. Okay, guys, this is the question. Thank you so much, Nishita Yadav. Thank you so much, Hitesh Pathak. I hope everybody understood. Sam Niran, I will give you the answer. You know what? I will post the answer. I will post the answer. Posting the answer in Telegram. Okay, I will post the answer in Telegram just for you. Okay. Alright, okay. Ritesh Pathak, I have done one micro course, but right now I don't have any micro courses going on. Okay, if I take any, I will tell you immediately. If I take any, I will tell you immediately. Alright, guys, so this is where I stop today's class. This is where I stop today's class. Thank you so much for coming here. Okay, thank you so much for coming here. If you have any doubts, then you can contact me at AADITYAP832 on Telegram. Okay, I am not on Instagram, I am only on Telegram. Okay, alright, guys, so I will stop here and I will see you guys in the next class. It was such a fun time. It was such a fun time teaching you today. If you have any topics in mind that you want me to cover tomorrow, please write them down in the comments. Okay, one shot videos. If you have any topics in mind, you can write them down in the comment section. I will do that tomorrow. Okay, guys, chalo, have a nice day, everybody. I will see you again tomorrow. Okay, bye bye. Bye.